So here is problem number 28 on topic 5, which is integration calculus. This odd-powered trig integral can sometimes be very tricky, rather sneaky, but it's not really that difficult. So let's see how to solve this. We want to evaluate the integral of sec³ of x. How do we go about this problem? To solve this problem, we need to first of all split up the second function, the cubic function, into two parts. One being secant of x and then secant squared of x. So if we split it up like this, makes life much easier. Now we make use of integration by part. If we integrate by part, we use the symbols as here's a formula for integration by part. So we are going to let one of these two one of the products, secant of x and secant squared of x, one of them is going to be u and the other one is going to be dv. So intentionally, because I know that the derivative of tan of x is secant squared of x, I'm going to let this be my dv. So I'll let secant of x be u and secant squared of x be my dv, like this. Okay, so let u represent sec x and dv be secant squared of x. If we do that, then by differentiating this, we get du being equal to, I think I want to do this quickly before we get into it. So u is sec x, which is basically 1 over cosine. So I can write cosine of x power -1. It's 1 over cosine. And so du becomes negative 1 over, or cosine of x power -2, which is 1 over cosine squared of x. And then differentiate the inside and I get sine. So this is going to be right here. I'll remove this. So this is going to be negative 1 over cosine squared of x, and then we differentiate the inside, and the derivative of cosine is negative sine, so that turns this into positive sine of x. And if you look at this, and of course this is dx, this can be simplified. There is sine over 1 of the cos, which is the same as tan of x, and then there is 1 over cosine that remains behind, and that is the same as sec of x dx. So the derivative of secant, this is the same as secant of x. The derivative of secant of x is tan x sec x dx, like that. All right, so that's what I'm going to place right there. Let's go on with it. All right, so if u is secant of x, then du becomes sec x tan x. And if the derivative, if dv is sec squared of x, then we know this is basically the reverse process. So v is going to be tan of x, okay? So v is going to be the tangent of x if dv is secant squared of x, all right? So now we know u, we know v, we know dv, and we know du. So all we have to do is substitute them there. And therefore the integral of sec³ x is the integral of sec x sec squared of x dx. So we're going to say this is going to be, so the integral of u dv, right? So this is my u here, u there, and this is my dv. So the integral of u dv is going to be u times v. So it's going to be u times b. So my u there, my u is sec x, and my v is tan x. So the integral is going to be, the first thing is sec x for u, all right, and tan x for v, so tan x, and then we're going to have to say minus the integral of v, our v is tan x, v, du, and our du is this expression here, right, like that, okay? So that's the integral. But when we look at this, you can see this is tan x and another tan x there. So I could actually represent this. I'll just write it here for the time being. This becomes tan squared of x times sec of x d of x, right? I can simplify that way. But tan x can also be expressed as sec² of x minus 1 into sec of x dx, like that. And if I open this bracket, I'm moving upwards so you can see this. If I open this bracket, I get sec³ of x minus sec of x, okay, everything dx, like that. So I could actually write this as just sec³ of x dx minus, so the integral, we're going to integrate sec³ of x dx minus integral of sec of x dx, like that. So I've simplified upwards. Please take a look at that and not see that you understand what's going on here. All right, so this expression simplifies to tan squared of x sec x. All right, tan squared of x from Pythagorean identity is sec² minus 1. If I open that bracket, I get sec³ of x, right, minus sec of x dx, which I can split up like that. And so this integral can now be expressed like this. Let's just put that neatly. So now that is sec of x times tan of x minus, and this time we write that as sec³ of x dx. And now it becomes plus because of this negative sign here. So that becomes plus sec of x dx. Okay, so go back to what we just did earlier. Because that was negative, negative is outside. So if we open that bracket, this was already negative. The negative sign from outside turns into a plus. Okay, so that then becomes our reduced form of that, of the integral of sec³ of x. All right, so next is just to write it down neatly now. So we've shown that this is that minus integral of sec³ of x plus integral of sec x dx. All right, so what we need to do is now solve these two. Now, we can see it looks like this is going to be some kind of circular argument because we are trying to integrate sec³ of x, but then sec³ of x appears here as well. But there is no problem really because this is minus. So what I'm going to do is just take it to the other side. It becomes positive, and now you'll have twice sec³ of x. When I move this to the other side, now I have two of them. So twice sec³ of x becomes sec of x times tan of x plus the integral of sec x, like that. All right, so that's how this reduces. Now this problem here, we've already solved it. I think it was problem number U523, if I'm not wrong. Yes, that's correct. So this is problem U523 in this series. So just go and take a look and see how we integrated that. We used backward reasoning and decided to multiply the top, multiply and divide by sec x plus tan x, right? So I will not go into that. Please just check video number 23 in the playlist on problems. All right, so then the integral of secant of x is just ln of sec x plus tan x, like that. And then of course we will say plus c. All right, so that is the integral, twice the integral of that. And so all I have to do now is divide everything by 2. And I end up with, if I divide everything by 2, end up with the secant³ of x being equal to a half of this, all right, plus a half of this, plus c. So this is, of course, a c here is different from that c, but there is no problem since it's a constant. We can use any symbol really. So you may choose to use a different symbol, a or k or whatever, or b. All right. So this is therefore the integral of secant³ of x. It's not very, very difficult if you already remember how to integrate this. Okay. Well, thank you very much. I'll see you for the next question.